Find the first and second derivatives of the function. So in part 1 we have this function. So first derivative means just find derivative once. So we got 3 terms, and by the sum difference rule we can find the derivative of each term. So x to the fourth is like x raised to n, and we know the power rule. When we have x raised to n, derivative is n x n minus 1. So x fourth means 4 x 4 minus 1, 3, minus second term is 3 times x cube is a product, but 3 is constant. When we have constant and a function, this constant survives. 3 here times x cube. For x cube we can use the power rule. So 3x 3 minus 1, 2, plus 7x, 7 times x, 7 survives, times derivative of x, which is 1. We can simplify this. This is 4x cubed minus 3 times 3, 9x squared, plus 7. And the question wants us to find second derivative, means we want to find derivative of this new function, which is already a derivative f prime. Now we want to find second derivative, f double prime. So this is for number 1. Second derivative is now, let's find the derivative of each term. Okay, like here. So using the power rule and following this rule, this is 3 times 4, 12x squared. I mean, you can check the details like this, minus 2 times 9, 18x, plus derivative of 7 is 0, plus 0. You don't have to write. Number 2. So let me rewrite this function because we have a fraction. 1 over x raised to 5. Move this up. So x raised to negative 5. And there's 1 on the top, that does not count. So 1 times this is just this. So this is the given function. Now we want to find first derivative using the power rule. So x raised to n, so n x n minus 1. So let me simplify. Negative 5 x negative 5 minus 1, negative 6. Okay, so we can get rid of this negative exponent putting this on the bottom, but we want to find second derivative as well, so I'm going to leave in this way. This is first derivative, f prime second derivative is now using the power rule. We just bring this to the front and multiply negative 5 minus negative 6, so negative negative positive 30, x negative 6 minus 1, that's negative 7. Okay, so you need to be careful when you are working with negative exponents. It's n minus 1, negative 6 minus 1, so negative 7. Okay, that's the second derivative. And if you want to get rid of this negative exponent, this is 30 over x raised to 7. This is negative 5 over x raised to 6, which is not needed, by the way. Number 3. So we have 5th root of x. So let me rewrite the function. So 5th root means x raised to 1/5. Okay, when you have 5th root of x, which is same as x raised to 1/5. Now this is like x raised to n. Let's find its derivative. First derivative is, this is like x raised to n. So n x n minus 1. 1/5 minus 1, negative 4/5. You can do here 1/5 minus 1. 1 is 5/5. So 1/5 minus 5/5 is negative 4/5. So we can get rid of this negative exponent putting on the bottom. That means with 5. But since we are finding second derivatives, I'm going to leave in this way. Second derivative is again 1/5 times this function. This constant survives when it comes with a function. I mean, if this is alone, then derivative is 0. So 1/5 here times x raised to n. From the power rule, n 4/5 x n minus 1, negative 4/5 minus 1. Let's simplify. Okay, here times negative 5, that's on the bottom, 25, negative 4 times 1, negative, so negative 4 over 5, 25. And here x raised to negative 4/5 minus 1. Okay, let's go back here again. This one is 5/5, this is negative 4/5. Okay, negative 4/5 minus 5/5, negative 4 minus 5, that's negative 9/5, negative 9/5. We can get rid of this negative exponent putting this on the bottom, but that's not needed, so this is it.